Numerical analysis introduction. Suppose if we consider a function y equal to f of x. Here what is x and what is y? We have y equal to f of x. Then that means x is the independent variable and y is the dependent variable. That means y values are dependent on x values, right? Suppose there is given a function y equal to f of x and the range of x is given. That means x is taking different values, that x0, x1, x2, so on, xn. That means range of x is between x0 and xn. Fine. x0 and xn. Right? So, for given such function, can we find the value of y corresponding to every value of x in this given range? My question is, can we find value of y for given x value in this range? For any given x value from this range, can we find y value? If y equal to f of x is defined, definitely we can find out. If y equal to f of x is defined, then we can definitely define, or we can say the other word is we know the function explicitly. Then we can definitely find the y values for any given x value in the range, right? Okay. Now my question is, if this function y is not explicitly known, I don't know what is y, the function. Suppose you have y equal to x cube. I know the function y equal to f of x is nothing but x cube. I keep on giving values for x equal to 0 implies y equal to f of 0, that is 0 power 3, 0. If x equal to 3, then y value equal to, I have f of 3. That means it is 3 cube. I know my answer. But if this function is not explicitly known, but what do I know? I know only the tabulated values of x and y in this way. See, if I have x, y, I have few values for x. Suppose I take the temperatures on day 1, or if I take at some year, in particular year, in 1990, I have temperature on particular day or a month. Average temperature in May in 1990 is 45 degrees. In 1992, it is 42 degrees. Then in 1994, I don't know what was the temperature. In 1996, it was 50 degrees. In 1998, it was 41 degrees. Suppose some tabulated values are given. I don't know the function over here. I don't know the function, but the tabulated values are given. If I want to find out the dependent value, that is y value, which is depending on x, what is at in 1994, if I want to know the temperature, can I find out, is my question. So the answer is yes, we can find out. Definitely we can find out. And here if you observe what is happening, I gave the tabulated values over here. Fine. So is this place or the position, is this in between the given range of x? Yes, this position is where I have to find. This position is in between the given range of x. When you are finding out the y value, in between the given range of x, it is called as interpolation. So, what is interpolation? Calculating or estimating the dependent value, that is y value, based on the independent value but within the given range of x. Then that process is called interpolation. And if this interpolation, if this process, in this process, if it is a polynomial, then it is called as polynomial interpolation. If what we are going to do, basically this is given, this tabulated values is for the function y equal to f of x, which is not known explicitly. That means I don't know the exact function over here, but I have the tabulated values, right? So what we are doing, we are going to find another function phi of x, another function phi of x, where both this f of x was satisfying this table. Yes or no? This y equal to f of x was satisfying this table. I am going to find another function phi of x, which will also satisfy the table values. In that way, I can find out the missing y values with this phi of x. This process is called interpolation. And suppose if this phi of x is a polynomial, then it is called as polynomial interpolation. And phi of x is called as interpolating polynomial. Process is called as polynomial interpolation. Phi of x is polynomial, process is called polynomial interpolation, and the polynomial is called interpolating polynomial. So you understood the word what is interpolation. Fine. Right? You understood the word what is interpolation. Fine. And also what is polynomial interpolation. Now just for a glance we'll see what is extrapolation. Extrapolation. From the word only you could guess what is extrapolation. It's the same thing. You have the uh, table, that is x and y values like this. Fine. So if some values were given x and y, I have x, y. I have x0, x1, x2, so on, xn. I have y0 corresponding values y1, y2, so on, yn. All the values are given over here. If I want to find some y value corresponding to some x value outside the table, outside the given set of values, if I want to find some y value, that is dependent value, outside the given range, then it is called as extrapolation. Fine. Both the words interpolation and extrapolation are fine. Now I'm coming into the exact topic. You have what is called as the unit numerical analysis unit 2. The heading is interpolation and polynomial approximation. Right? So this interpolation, in what you are going to learn is with uniform spacing of dependent variable. What is uniform spacing of dependent variable? What's the meaning of that? That means the x variable is uniformly spaced. X variable, dependent variable is nothing but the x variable is uniformly spaced. Fine.